Hello, I'm Rachel Park and welcome to this episode of the MTC3 Interview Series. Today I will be speaking with Professor Peter Mayr from the Technical University of Munich. Hi Peter. I think just to start, could you tell us a little bit about your background with additive manufacturing?
Yeah, I received a perfect education at Graz University of Technology in mechanical engineering and I had the opportunity to go to MIT as a postdoc for 1 year, and basically directly from there I was appointed as a full professor at Chemnitz University of Technology in welding engineering. And welding is very similar to additive manufacturing, and just recently, so in September of this year, I was appointed as professor in materials engineering of additive manufacturing here at TUM.
So TUM has a very long and well-established history when it comes to research and development for general engineering and manufacturing. But how does this impact your current work at the university, or the work that is ongoing at the university, when it specifically comes to relatively new manufacturing processes such as additive manufacturing?
Yeah, I think the president of our university, Professor Hofmann, and also the dean of mechanical engineering have pointed this out in their opening speech quite precisely. So TUM sees very high potential in additive manufacturing and wants to strengthen its role and even further increase their efforts in additive manufacturing. And it's very easy to go back to the basic resources of the university. So we have the brightest researchers across various disciplines, so from medical to engineering. We have very clever students, highly motivated young individuals, very clever heads that can translate their ideas into startups. And we have within this area of Munich, we have a very strong industry that also drives us forward and that supports our ideas.
Absolutely. So in general terms then, how do you see additive manufacturing fitting into the current industrial manufacturing landscape? How far is it going to penetrate, and how can it penetrate into industry?
Let me first point out, we all speak about additive manufacturing. But in reality, it's not a single technology. So additive manufacturing covers a variety of production technologies, ranging from technologies using electron beam, laser, electric arc, sintering, diffusion bonding. So I haven't spoken a word about materials or other processes that come before the manufacturing, like design or post-processing. So we are talking about a huge and highly complex area. Regarding the translation to industry, every industry has adopted additive manufacturing already in their plan. And you see it very often, all high-level companies, they do something additive because it's called sexy. But when you have a closer look, they often copy existing parts that can be produced by conventional technologies using additive manufacturing. And that should be not the goal of additive, because then you lose the added value. You need new products, new business cases where you can apply additive manufacturing. There are especially the startups, new companies that adopt additive manufacturing and that come in with completely new ideas and new products. And I think the big players in industry, they still have to find their way in additive manufacturing. When you look, for example, at a rocket, it's nice to have an AM part in it. But how many rockets are flying into the orbit? Yeah. So 16 parts, it's not much in additive manufacturing. I think the whole business has to grow.
So are you saying with that you think that established companies are finding it harder than the newer, sort of more innovative tech startups?
I think so, because they are not as agile as
Yes.
small startups. And the reality is additive manufacturing wakes the little kid in us. So you have an idea, you translate it into a plan, you go to a machine and you print something, and immediately or after a couple of hours you hold something in your hand and you see what has become from your idea. This creativity is often lost in larger companies where you have to follow strict rules and there is
Processes, procedures,
hierarchy.
yes.
So the idea of startups is nice and really promoting additive manufacturing.
But is there maybe a way that you see that we could have overcome those problems in the larger companies where the hierarchy exists?
I think so, and it's fantastic to see here at this conference how the big players like Oerlikon or Linde are promoting the topic, how they are linking companies. They are not in competition with them. They have identified that for additive manufacturing we have to pool our knowledge and promote this idea further.
Getting a little bit more specific about your role at TUM then, what are your primary areas of research with additive manufacturing that you're involved with? Is there anything you could tell us about those?
Sure. So I'm a professor of materials engineering of additive manufacturing. So my main interest, of course, is in the materials aspects of additive manufacturing. And this is also a very wide area, ranging from the development of feedstock materials for additive manufacturing. This is a huge field because so far many companies just put a sticker on their existing feedstock AM qualified. But the potential here is enormous, developing new materials specifically for AM purposes. And the second area I'm working on is the characterization of printed parts and looking at the materials, how they behave and what properties you can expect from such components.
So materials are obviously vitally important to the whole additive manufacturing ecosystem, but can you go into a little bit more detail about what sorts of materials you're working with? Is it powders, is it polymer, resins, or are you across the spectrum? Is it metals?
I'm qualified as a welding engineer, so all my past research was devoted to metals.
Okay.
And also my research in additive is on metals. But I would not restrict it to any form of the feedstock. So we are looking at powders.
Okay.
There are numerous different variants of powders, but we are also looking at wires, even at sheet material, because I see high potential in sheet laminated additive manufacturing,
really?
where you just staple sheets and can create, for example, self-healing structures. So, and that's a fantastic idea. You damage a material by, for example, neutron irradiation, and it heals itself.
Oh wow.
And this can take place in materials of niobium copper. If you staple it, it develops this function.
I was actually going to ask you, so when you say copper, you're looking at new types of materials that, apart from what's already being used?
Yeah.
With AM at the moment. So what sort of applications do you see those driving into?
So this development was specifically for nuclear fusion. So the first wall that gets in contact with the high plasma, that would be of this material. And that is also typical for additive manufacturing. At the moment, I see a lot of applications in very expensive industries, for example, in medical or aviation. Our goal should also be to bring additive manufacturing to everyday life. So to make the technology cheaper.
Okay.
So to create
more widespread.
Yeah, more widespread. So with the thermoplastic printers is almost a reality at the moment.
Yes.
Even children have it at home and print their little figures. So I see high potential also for the metal side.
So some of the things you're talking about there could be classed as revolutionary, and quite often, particularly in the press, that's how it is referred. What are your thoughts on that?
I see it a little bit different. Of course, as I mentioned, additive manufacturing is now very sexy, and everyone is talking about it, and it's just sparking the creativity in all of us. But for a revolution, I think it's not there yet. A revolution is always driven also by the people that adopt something, and if all of us adopt additive manufacturing, do research on it, companies produce machines even more for additive manufacturing, and the additive parts come into our daily life, then I think then the goal is reached, but I wouldn't call it a revolution. There are so many production technologies out there, and they will be out there in 100 years.
Yes.
But additive will be a new one complementing the portfolio of production technology.
That's absolutely the key word, isn't it? Complementing it.
Yes.
It's a new alternative that can give us different advantages. Is that how you see it?
Yes, definitely. And my research goes, for example, in the direction of producing graded structures. So you start printing with material A and end with material B.
Okay.
Or you have material A, the majority of your part is material A, but on certain spots you have material B with different properties. And this is something you cannot achieve so easily with conventional production technologies. So also we as a researcher, we have to find our focus in additive manufacturing.
I know how important the research is, I'm sure most people do, but how does that translate to industrializing AM? How do you push that out further into industry from within TUM?
Yeah, I think TUM as the entrepreneurial university, I mentioned the startups that basically form the foundation for the upcoming industry. So in 50 years, but we also support our big players with new ideas. We, as a university, as a researcher at the university, we have the freedom to have crazy ideas, to follow some ideas where the goal is not clear at the beginning, and so spark industry with new ideas, and I think this
and
also
work with them,
of course, and so support them.
I think that's a really good place to end. So thank you so much for your time today, Peter.
It was a pleasure. Thank you.